Welcome back to CS520. I just want to say a few quick words about Makefiles. We'll be using Makefiles throughout the course to coordinate the sharing of code between you and me. And if you've never seen these, they're fairly simple and you should understand basically how they work. I'm not going to tell you everything there is to know about Makefiles, though. There's lots of bells and whistles. I'm just going to try to explain to you the basic features available through the concept of a Makefile. And I'll do it by the Makefile that I distributed for Lab 4. Let's take a look at that. All right, very simple. You notice the Makefiles, first of all, can start with comment lines. And then there's a series of definitions. And you're defining a dependency graph for the pieces of the program. So one way to read this is the following. The Lab 4 executable is dependent on, that's what the colon really means, is dependent on having a main.o and a simtab.o. In other words, we need to have those two object files in order to build the executable called Lab 4. And these rules are connected to actions for how to complete the rule. So given these two O files, I can run GCC to link them together, and I can call the output Lab 4 producing the left-hand side of the rule. Then main.o is of course dependent on main.c and a header file simtab.h. So if I want to build that, I've got to have these two pieces, and then here's the action, again running the C compiler to generate an O file. And similarly, simtab.o is dependent upon simtab.c and simtab.h, and again here's the action for building simtab.o. So if you look at that, there is a dependency graph here. Lab 4 is dependent upon main.o and simtab.o. And then main.o is dependent upon main.c and simtab.h. And simtab.o is dependent upon simtab.h and simtab.c. So what make does when you execute it is it says, okay, if you want the goal to be Lab 4, I go look for the components that are needed, and if main.o is not present, then I'm going to essentially recursively call myself to make main.o and come down here and look for these components. If these components are not present, since I don't have a rule to produce them, then the make will fail. Similarly, down this path, same thing. Lab 4 will come down here looking for a simtab.o. If it doesn't exist, it will build simtab.o from these two files and then recurse back. Once it has the main.o and sim.o, then it can generate Lab 4. Moreover, the tool checks timestamps. So if you want to build Lab 4 and you already have a Lab 4, but the Lab 4 is dated before one of the components below it. For instance, if you've edited main.c recently but haven't rebuilt anything yet, Make will come down here and say, I want to build Lab 4, so I need main.o. Main.o is dependent on main.c. Oh, wait a minute, main.c is newer than main.o. That means I have to regenerate main.o. And since I regenerated main.o, I've got to regenerate Lab 4. So if you had only edited main.c and had not edited simtab.c, it would only rebuild the main.o and then the link to form Lab 4. So it's smart. It figures out what has to be remade given the timestamps on the files. How do you use this? Well, if you're in the directory where the Makefile exists and you want to make the default item, which is the first item in the file, then you can just say, again, at the shell prompt, which I'm saying is the % sign here, I can just say make. Or if I want to make something that's not the default, I could just say make simtab.o, for instance. Usually Makefiles have a rule for clean, which actually is not dependent on anything. and all it does is clean up any temporary files. So it removes, in this case, it removes the executable and the object files. Clean will always run because you don't produce a file called clean, so the system always thinks you need to run the action. The trickiest thing about Makefiles is that this is one place in life where I have to use tabs. These action lines begin with a tab character. Honest to God, tab. I'll write that in here. There's a tab here also. Those action lines, this is ancient 70s era syntax. That's just how it works. It looks for a tab line to tell it that it's an action line. So if you've configured your editor to not place tabs in the output file, this is one time when you've got to change that. So that's Makefiles fundamentals. Again, there's lots of bells and whistles. For instance, if you look at the Makefile for program 2, you'll see that I often don't specify the actions. That's because you can often have the actions default. Make is smart enough to know that if you're building a semtab.o from a semtab.c, it will know how to do that, how to run GCC and do that. There's also some convenient macros that I use, so C flags, C compiler. I can actually define macros so that I can pick up things like this, get those inserted everywhere automatically. These would be C flags. CC, I might bind it to be GCC. If I was in an environment where I had multiple C compilers and I wanted to choose one. Again, you'll see examples of that in the Makefile for program 2. And then, there's lots of other things you can do too, and I recommend looking at a reference for Make if you're interested in learning more about how to build complicated Makefiles.